Hi guys, Mark Franke here. This video is the problems for chapter 23 on decision-making models. And we're going to start with problem 23-1b, which is a problem where we have been offered a new piece of business below our regular selling price. This is a situation where we are currently selling 300,000 units at $4 a piece. And what I have done here is I've put in the information from that's given to you in the problem and calculated a per unit amount of what's existing and then categorizing the expenses into their fixed and variable components. So if you want to pause the video for now and put this information in on a worksheet that I provided, that's fine. So first thing I'm going to do is calculate the variable cost per unit. And for the materials, direct materials, it's going to be the same as the per unit we've already calculated. This is just for variable cost, and because materials and labor are totally variable, we're going to get the same $1.28 and 32 cents. But for overhead, variable overhead, I'm going to divide that by 300,000 units and get 72 cents. So our total variable cost per unit is $2.32. That's the relevant cost in accepting this new business. So we can see that the $2.32 is below what our offer price is. This company has offered to buy 50,000 units of our product at $3.44 for a total sales of 172,000. So we'll plug that in here, and our job is to figure out are we going to make money? And besides our variable cost, the only fixed cost that we will incur is an additional $4,000 in administrative expenses. So I'll plug that in here. And now I'm going to calculate the direct materials by multiplying our variable cost of $1.28 times 50,000 units. That's $64,000. They told us that we're going to have to pay an overtime premium. So I'll take the 32 cents times 50,000 units times 1.5, which is a time and a half overtime premium. And then we'll have our variable cost of 72 cents times 50,000 units, 36,000. We won't have any additional fixed factory overhead. So our total product cost for this new piece of business only is just the variable cost. And when I subtract the variable cost from sales, I get 48,000 in gross profit. That's also our contribution margin, but we're not doing a contribution margin income statement here. And then if I subtract the $4,000 fixed cost from our gross profit, that means that this new piece of business is going to generate $44,000 worth of additional profit. And when I combine these columns together, we'll see that our net income, including what we're currently doing and this new piece of business, is going to go up. And so we should accept this business because our profits will increase. In fact, our profits will be $276,000 on sales of $1,372,000. So the decision to accept this would be good. Now there are some non-financial things. Will it compete with our existing products? Will it cause any of our customers to get upset because we're selling it at a cheaper price? But strictly from a financial standpoint, this is a good decision. Problem 3B is a make or buy decision. So we can buy the part at $4, and they've given us information that what is the cost of making the part. And in this case, we have some direct materials, and this is per piece, $1.20. We have direct labor of $1.50, and we have factory overhead, which is 25% variable. That's $1.50. So we're taking into account our variable costs. So our total relevant cost is $4.20. It cost us $4 to buy the part, so there's an advantage of 20 cents per part to just go ahead and buy it. We need 200,000 of these, 400,000 of these. So we're going to save $80,000 by buying this part. Problem 23.3b. So what we should do is put a decision down here. Uh-oh. The company should buy the part. Make it clear to the reader that this is the decision you think we should do. Problem 23.4b is a situation where we have actually 3 alternatives in this particular scenario. We can sell to a wholesaler. These are parts that have some sort of a defect that we would have to rework them. But we could do one of 3 things. We could sell it to a wholesaler who doesn't care that these are defective. We could sell them to a recycler just to get the scrap value for them. Or we could rework them and then sell them as new units. So we're going to do incremental revenue and incremental cost of these 3 scenarios and then compare which one is the best. So if we sell it to a reseller, we're going to get 7,500 units at $75 a piece. And there is no incremental cost to this. We're basically just selling them as is. So we're going to get $562,500. If we sell it to a recycler is willing to pay $130 per unit, but in order to extract whatever it is, maybe there's silver or something in the product that we can extract, it's going to cost us $400,000, but we're going to net $575,000, which is better than alternative 1. So far, alternative 2 is the best option. And then the third option is to sell it as new, and these are still $7,500, but when we sell them as new, it cost us, we get $500 a piece, so that's going to be $3,750,000, but the rework cost is $3.2 million. So alternative 2 is still, in this particular case, the best option. So we're going to say Micron should choose alternative 2 as it provides the highest income or profit. Problem 23.4b. Problem 23.5b is a product mix problem. And I've set this up. We have two products. This is the Sung Company. And this is a product mix analysis, where we're going to compare two products, product R and product T, that use the same machine. So we have to decide how much of product R, how much of product T are going to be processed based on our demand. And the first calculation is to figure out what the contribution margin is per machine hour. Product R sells for $60, has a variable cost of $20, so contribution margin per unit is $40. Product T sells for $80, has a variable cost per unit of $45, so has contribution of $35 per unit. It takes 0.4 hours to make product R, and it takes 1 hour to make product T. And our maximum sales units is 550 of product R. In other words, we can sell up to 550 units, and then the demand drops off. And we can sell 175 units of product T. So now I can calculate the contribution margin per machine hour by taking the contribution margin per unit and dividing it by the machine hours per unit. So for product R, we are going to make contribution of $100, and for product T, we're going to make contribution of $35. Why? Because we get contribution per unit of $40 per unit of R, and we can make 2.5 of these per hour. Basically 0.4 machine hours per unit means that we can make 2.5 of these. So if we multiply 2.5 times 40, we get $100. So what this means is we need to make product R first, because that has the highest contribution margin. So, and let me make this a little smaller. Our number of hours per shift is 8. We can work 22 work days per month, so that gives us total machine hours of 176 hours. So if we produce 2.5 units per hour, we can produce 440 units of product R. But that's still less than the maximum number we're going to get contribution of $40. So our total contribution is 17,600. We should make all product R. In other words, we're not making product T anymore because we don't have enough hours available. So in the hours we do have available, which is 176 hours, we're going to make all product R, and we're not going to make any of product T because we haven't maxed out on product R yet. Okay, so management says, well, let's talk about adding an additional shift. This is requirement 3. If we add an additional shift, that means we're going to have another 176 hours, and we can finish making as many of product R as we possibly can, which is 110, because we made 440 in the first shift, so we're going to make the additional 110, and we still get a contribution of $40. So our additional contribution from R is going to be 4,400. In other words, if we put in a second shift, first thing we're going to do is finish up making product R, and then we can make product T. I'm going to stop the video and fill in the rest of requirement 3, and I'll be right back. Okay, so I've done the analysis on adding the additional shift, and based on this analysis, our contribution margin is going to increase $5,770. So our total contribution for both shifts will be $23,370, which is the $17,600 from the first shift and this $57.70 from the second shift. So it's a good decision to add this second shift because our contribution is going to go up. Now, the last requirement is, what would if we did some additional marketing and we'd be able to increase our third requirement is to evaluate whether or not they spend an additional marketing cost of $4,500, which will increase the maximum unit sales of product R from 550 to 675. So now the additional units is going to be 235. We're still getting $40 in contribution. So our additional contribution is $9,400. And we're going to do, in effect, the same analysis that we just did, but because we made more of product R, we have less time available for product T. So I'm going to pause the video. I'm going to drop these numbers in, and we'll see whether or not this is a good idea or not. Okay, so here's the numbers for the additional marketing plan. This is the last requirement. And you can see that our contribution margin goes down from our second scenario. So this would not be a good idea. So this particular problem, we should add the second shift, but we should not do the marketing plan. What's happening is the additional marketing costs of $4,500 is not offset by the additional contribution that we would generate from doing this marketing plan. So that's it for chapter 23 problems. I'll talk to you again soon. Bye-bye.